Hello, my name is Matthew, and today I will be going over section 1.8, question 6 on local linearization. So a potato is placed in an oven, and the potato's temperature F in degrees Fahrenheit at various points in time is taken and recorded in the following table. The time T is measured in minutes. So the first question asks us to use a central difference to estimate F prime of 60, and to use this estimate as needed in the following questions. So to start, since we're going to be using the data points given to us under estimates, so we have our underestimate, which is going to be from using the central difference between f of 75 and f of 60. So eventually, we get using these points, 342.8 minus 324.5 over 15 minutes, which leads us to a instantaneous slope, an estimate of f prime of 60 of 1.22 degrees per minute. Now this is the underestimate because, as you can kind of see here, going from our middle point 60 to the right point 75, it is lower than what the actual slope would possibly be. So we have our underestimate, which is just from 45 to 60, which gives us 324.5 degrees over 296 degrees, or minus 296 degrees over 15 minutes, and that ends up being 1.9 degrees per minute. And this is going to be our overestimate because, as we can see here, it's going to give us a slope that would be larger than what the actual slope at 60 would be. So the next question asks us to find the local linearization of y equals lt to the function y equals f of t at the point where a equals 60. So we start with our equation, which is going to be f prime of a times x minus a plus f of a. And when we plug all those values in, we're going to use our underestimate. So we have 1.22 times x minus 60 plus 324.5. And so it's the equation we get for an estimate of what the equation of this black tangent line up here would be. Then on to the next question, we are due to determine an estimate for f prime of 63 by employing the local linearization. So it's pretty simple. We just take our equation we created above, plug in 63, and we end up with a number of 328.16. And this makes sense when we look at our values because it falls somewhere in the middle number between f of 60 and f of 75. And that leads us to the next question, which is, do we think this estimate is too large or too small, and why? This estimate would be too large because essentially what we're doing is estimating a tangent line that's going to be above. We're estimating something that's going to end up falling above the actual graph. So the actual value of f of 63 is going to be smaller than what we got up here, which was 328.16.